Expansion of perfect squares and difference of two squares. In Sec 1, you learn about perfect squares, okay? Like for example, 1 squared is equals to 1, and so this 1 here is a perfect square. Or if you say that 2 squared is 4, then 4 is a perfect square. So likewise, 9 is a perfect square because it is 3 squared, okay? And so on. Now any number squared is the number multiplied by itself twice, okay? Not multiplied by 2, but multiplied by itself twice. For example, 3 squared is equals to 3 times 3, right? 3 multiplied by itself twice. So in the same way, a plus b bracket square is a plus b times a plus b. If we use the rules of expansion earlier on that we learned, then you see that the a will multiply by the a multiplied by the b multiplied by a, b multiplied by b. And this gives us a squared, ab plus ab. BA is still AB, right? So I'll write here plus AB as well. Then you have plus BB, which is B squared. And again, you see that this AB here and the AB here, they are like them, so you add up. So this becomes A squared plus 2AB plus B squared. Now, what if we change this plus to a minus? Then this is what happens. You have A minus B times A minus B. And this becomes a times a is a squared. Negative b times a is negative ab. Then you have a times negative b, which is negative ab again. Watch this, negative b times negative b is positive b squared. Like terms, negative ab, so a squared minus ab is minus 2ab plus b squared. Okay, let's pause for a moment. What this topic is really expecting you to do is, whenever you see that you have this a plus b bracket square, you straight away multiply it to become a squared plus 2ab plus b squared, okay, using this formula. Or if you have a minus b bracket square, then you have a squared minus 2ab plus b squared. You expand out using this formula straight away, okay? Instead of going through this entire series of steps, you are expected to use the formula to expand this. And I think that's one of the very big struggles that students go through at the beginning. And yeah, most of the students will just go through all these steps, okay? But you have to get used to it to wean off yourself from expanding like this. Right, now let's look at difference of two squares. You have a plus b, a minus b. Now in this case, you see that both brackets are the same, a plus b, or a minus b, a minus b. So here you have a mixture, right? A plus b, a minus b. One positive, one negative. And we see what happens. A times a squared. A times negative b is minus ab. Positive b times a is positive ab. And then b times negative b is minus b squared. And you have this minus ab plus ab. These two will cancel off because one negative and one positive. And as a result, you will get a squared minus b squared, which is why it is called the difference minusing of two squares, okay? A squared minus b squared. Yeah, so a squared minus b squared is going to give you a plus b, a minus b. You have to recognize this, and whenever you see this, you change into a squared minus b squared. And the converse is true, which means that if you see a squared minus b squared, you can factorize it into a plus b times a minus b. Example 3, expansions of perfect squares and difference of two squares. So here we expand each of the following. You have 2x plus 3 bracket square. Now let's compare this with the formula, which is a plus b bracket square. And this is equals to a squared plus 2ab plus b squared. Now, if you make a comparison, you can see that this a here is the 2x. This b here is the 3, right? So we say that a is equals to 2x and b is equals to 3. So using this formula, we can straight away expand this to become a squared, a is 2x, so you have 2x bracket squared plus 2ab, a is 2x, again, b is 3, plus b squared. So plus 3 squared. Okay, let's simplify this. This one, there's a bracket square and there are two parts in there. There's a 2, it takes a square. There's an x, it takes a square as well. Okay, so the 2 square is 4, x square is x squared. 2 times 2 is 4, 4 times 3 is 12, okay, plus 12, and you have an x here, 12x, plus 3 square is 9. Okay, this is your part A. Part B, you have 5x minus 7y bracket square. Let's look at the formula here. You have a minus b bracket square, right? Yeah, because you can see the minus sign here, so it's a minus b bracket square is equals to a squared minus 2ab plus b squared. And from here, you can see that the a is 5x, the b is 7y, okay? B is equals to 7y. Now, don't worry about this negative sign, the formula takes care of it. Okay, so you don't try to sub a negative 7y into the formula, because this negative sign has already been taken care of by the formula. And so you have a squared minus 2ab plus b squared, right? A is 5x, so you have 5x bracket square minus 2ab. A is 5x, b is 7y. So I write side by side. They're going to be multiplied together. Plus b squared, so you have plus 7y bracket squared. Okay, so 5 gets the square, x gets the square. You got 25 x squared minus 2, 5, 10. 10 times 7 is 70. 70, then you see this x here and y here. Yeah, so 70xy plus 7, 7, 49, y squared. Okay, that's it for part B. Part C, we have 6 bracket 4y minus x bracket square. Now, it is tempting for you to think that this 6 could be multiplied in straight away. Okay, 6 times 4y, 6 times negative x. Okay, that's not correct, because according to Bodmer's rule, whatever that is in the brackets and whatever is taking order, that means powers, has to come before whatever is dividing and multiplying. Okay, so you can see this 4y minus x goes first because it's in the bracket, and then the square goes next, then the multiply next. Okay, so you please do not multiply in this first. You expand this bracket square first, then you multiply in the 6. So before we continue, the a, if you can see it, is 4y. The b is x. Okay, so if you expand this, we leave the 6 alone. 4y bracket square, okay, if you can do this mentally, it'd be really good. So you can see that it's 4 is 16. Y is y squared. Minus 2 times this, right? So 2 times 4 is 8. Y, 8y. 8y times x is 8xy. Okay, so you have 8xy. Xx is x squared. Yeah. So eventually you have to come to this where you can do this entire sum by mental calculation, right? So 6 times 16, okay, here you may need calculator, so let's do that. 6 times 16 is 96. So you have 96 y squared minus 6 times 8 is 48 xy plus 6x squared. Okay, and you're done. Okay, y squared, xy, x squared, they can't be simplified, so you just leave it as it is. Now let's look at part D. Xy plus 1 times xy minus 1. Okay, now you could multiply it like the usual way. This, right? But let's not do that. Let's just pause for a moment and recognize it for what it is. If this is a, and then this is plus b, that means a is xy, b is 1. Then this will be a minus b, isn't it? So if you have a plus b times a minus b, that's equivalent to a squared minus b squared. Okay, remember this formula and recognize the pattern as well. So straight away we say that this is xy bracket square minus 1 bracket square, and that gives us x squared y squared minus 1. Part E, 2 bracket 3 plus x, 3 minus x. Now in this case, if you're multiplying the two, you will not be wrong. But I wouldn't do that because straight away I recognize that this is a plus b, a minus b. So I'll leave the 2 alone first, and I have 3 squared in the bracket minus x squared in the bracket, and you have 2 times of 9 minus x squared. So if you expand this, 2 times 9 is 18 minus 2x squared. Alright, you give it a try. Share with me what questions you have in the comment section below. Please like this video if you have enjoyed it. Hit the bell button and subscribe. Thanks and see you in the next video.